A Siberian tiger can weigh up to 600 pounds. It is an animal defined by immense muscle density, built to overpower prey significantly larger than itself. But the cat family is a study in extremes. At the other end of the spectrum is the 10-pound domestic house cat. While these two species seem worlds apart, their DNA tells a different story. If we trace their genetic markers backward, every branch of the modern feline family tree converges on a single starting point. That point is Proailurus. Known as the first cat, it lived between 25 and 35 million years ago, emerging during the Oligocene epoch in the forests of Europe and Asia. To understand how the cats of today became such dominant predators, we have to look at this ancient root, a creature that actually looked very little like the felines we know. Proailurus was a compact animal, weighing only about 20 pounds.
It possessed a flattened skull and a jaw that still held on to extra teeth, remnants of its ancestors that more specialized cats would eventually lose. Proailurus was semi-plantigrade, walking flat on its soles with heels striking the ground. While slow on the ground, this flat-footed stability was highly effective for stalking prey within the vertical canopy of dense ancient forests. But the environment was changing. As the global climate cooled, these expansive forests began to retreat, replaced by more open woodlands and seasonal grasslands. The vanishing tree cover presented a crisis. For this branch of the family tree to survive in an exposed world, the physical structure of the cat had to undergo a fundamental transformation. By the Miocene epoch, roughly 20 million years ago, a new genus emerged to fill this shifting landscape, Pseudaelurus. Pseudaelurus represented a significant increase in physical presence, reaching proportions comparable to a modern cougar. But the real breakthrough wasn't just its size, it was how the body moved. These cats moved to a fully digitigrade stance, walking entirely on their toes. By lifting the heel off the ground, the leg essentially became longer and more spring-loaded, providing a massive boost to running speed and stride length. The teeth were also changing. Pseudaelurus developed a highly specialized hypercarnivorous dentition. Its teeth were no longer general purpose, they were strictly designed for the efficient slicing of meat. With the combination of increased scale, rapid toe-walking speed, and specialized slicing teeth, the foundational physical traits that define modern felids were now present in a single animal. This specialized set of traits allowed Pseudaelurus to expand rapidly across the globe, moving out of Asia and establishing itself throughout Europe and Africa. Roughly 18.5 million years ago, Pseudaelurus crossed the Beringia land bridge into North America. This migration ended a 7 million-year cat gap, reintroducing felines to a landscape absent of them since the Oligocene. But Pseudaelurus was also a crossroads. It was from this group that the cat family fractured into two distinct paths, the famous saber-toothed cats of the extinct Macdonald and the conical-toothed cats that would lead to the present day. This genus acted as the biological distribution hub for the entire family, seeding nearly every corner of the planet with the ancestors of future lineages. By 11 million years ago, the timeline narrows to a specific population of conical-toothed cats living in Asia. Genetic tracing confirms that every single cat alive today, from the leopard to the tabby, shares this exact group of ancestors as their most recent common link. While their saber-toothed cousins would eventually vanish, these survivors became the root from which all modern feline diversity would bloom. From a single Asian node, the family tree branched into 8 lineages. The Panthera line, the roaring big cats, diverged first, roughly 10.8 million years ago. Geographic splits then gave rise to the caracal, lynx, puma, and eventually the domestic cat lineages. As sea levels fluctuated and land bridges formed, these lineages spread back across the continents, each adapting to their specific environments, from snow-covered mountains to arid deserts. While every modern lineage has spent millions of years specializing for its niche, they all still rely on the foundational mechanics established during the Miocene. The successful template of the toe-walking, meat-slicing predator proved so effective that the core of the cat's identity has remained remarkably consistent ever since.